Welcome to sixth grade math. That was your homework that was due today. 4.2 mini lab. We're going to talk about equivalent fractions. Fractions are often used to describe the relationship between part of a set of objects and the whole set. So 3/5 of the counters are red. 6/10 of the counters are red. So in the above examples, 3/5, 3 of the 5 total, so 3 is the part that are red of the 5 whole set of 5. Fractions are often used to describe the relationship between part and whole, are said to be equivalent. In the models shown, 3 out of every 5 groups of counters are red. Therefore, 3/5 and 6/10 are equivalent fractions. In the example above, 3/5, denominator represents a number of red and blue dots, so the total, like I just mentioned. And 3, the numerator represents the number of red dots. Activity: use counters to generate a fraction equivalent to 2/3. Step 1, model 2/3 by forming a group of counters in which 2 out of 3 are red. So there we go. There's 3 counters or dots, and 2 of them are red. Step 2, combine 2 or more equal groups to form one larger group. So we have 3 groups of that group demonstrated above in step 1. And step 3, name the fraction of the larger group that is red. So we have 3 groups of 2/3. So we have 6/9 of the larger group is red. So one fraction equivalent to 2/3 is 6/9. Check your progress. Use counters to name 3 fraction equivalents to each fraction. 3/4. So that's what 3/4 could look like. 3 out of 4 counters are red. We could do 6 out of 8 counters are red. Notice that it's 2 squares of the one that's showing for 3/4. And then we have 9/12, which all that is 3 groups of the 1 for 3/4. And then we could have 12/16, which again is just 4 groups of the 1 for 3/4. 1/3, so 1 out of the 3 counters are red. If we have 2 of those groups, we end up with 2/6. If we have 3 of those groups, we end up with 3/9. And if we have 4 of those groups, we end up with 4/12. So 2/5, 2 out of the 5 counters are red, so we have 2/5. And now we have 2 groups of 2/5, so that's 4/10. 3 groups of 2/5 is 6/15. And 4 groups of 2/5 is 8/20. Then we have 5/6. So 5 out of the 6 counters are red. We have 2 groups of 5/6, which is 10/12. 3 groups of 5/6, which is 15/18. And 4 groups of 5/6, which is 20/24. Simplifying fractions. Generate equivalent fractions by separating a larger group into 2 or more smaller groups that share the same part to whole relationship. Use counters to generate a simpler fraction that is equivalent to 6/12. So model 6/12 by using counters. So there we have 6 red and 6 blue, so in total it's 12, but 6 out of the 12 are red. So separate the counters into equal groups so the relationship between the red counters and total number of counters in each group is the same. So you've noticed that we still have 6/12, but now we have 2 groups of 3/6. In step 3, name the fraction of each smaller group that is red. 3 out of 6, or 3/6 of each smaller group is red. So one simpler fractional equivalent to 6/12 is 3/6. Equivalent fractions. There may be more than one simpler fraction that is equivalent to a given fraction. For example, you could also separate the 12 counters into equal groups of 2 counters where 1 counter in each group is red. So 6/12 also equals 1/2. Use counters to name a simpler fraction that is equivalent to each fraction. 10/16. So if we split those up, we have two groups of 5/8. 6/21. So we have 6/21, but we could split that up into three groups of 2/7. Notice it's three groups now. And then we have 8/24. There's 8 out of 24 red, but if we split those up into four groups of 2/6. 24/30. 24 out of 30 are red. Notice we split those up into three groups. We have 8 out of 10 are red. Analyze results. In activity 1, an equivalent fraction is created by combining equal groups that have the same number of red counters and the same number of total counters. What operation does this model? Multiplication. Make a conjecture. Use the operation you found in question 1 to generate a fraction equivalent to 7/8. Justify your answer. So 7/8 equals 7 times 2 and 8 times 2 equals 14/16. In activity 2, an equivalent fraction is created by separating a group of counters into equal groups that have the same number of red counters and the same number of total counters. What operation does this model? So we separated, so we divided, so division. Make a conjecture. Use the operation you found in question 3 to generate a fraction equivalent to 30/40. Justify your answer. And if we have 30/40, we could divide by 5, and we would end up with 6/8. And there's no homework tonight. So enjoy your evening. I'll see you tomorrow.